Howdy, my name's Samuel Haggerty.
I'm Sean Martinez.
I'm Kian Jepson.
I'm Nicholas Reichert.
Our project revolved around making a security patrol robot. So the initial mission was a robot that utilizes simultaneous localization and mapping to map the entire indoor environment. That map would then be used to create patrol paths and determine points that it would follow. While on this path, it would notice unanticipated objects or people in the environment using the LiDAR, at which point it would then point towards them, sound an alarm or buzzer whenever that person was detected by the LiDAR. What ended up coming from the final outcome was the scuttle that utilizes the LiDAR, except now it travels along a given wall that it finds within the room. It then comes up to a corner, faces directly away from the corner, and produces a global scan of the room using the LiDAR. And then it compares following scans to the initial global scan, and it detects any changes. If there's a change, then it will turn and actuate a servo, which will fire the Nerf gun. If it does not detect a change, it will return to its path. It will return to its path regardless of if it fires or not, but it shoots first, or maybe.
This is the scuttle that was used. In addition to the scuttle, we have the LiDAR, which is seen up front. And then on the back, we have a Nerf gun. And then attached to the Nerf gun, there's a servo motor, which has a pencil on it that helps pull the trigger of the Nerf gun.
So some difficulties that we did run into was the Nerf gun was struggling to fire consistently. Either the trigger couldn't got jammed, or a Nerf gun bullet got jammed. So that was some problems there. The next thing was some Raspberry Pi connectivity issues due to poor Wi-Fi. We would be in the middle of writing some new code, and we would have to enter the password again to get back into the scuttle. Then the next thing that did happen that did set us back quite a bit was the VS Code issues after an auto update. We did have a setback given that we did not know what the issue was till we realized it was a VS Code update. So we had to go back and downgrade a version. And then the last thing was we were unable to achieve all mission statements due to technology restrictions. And it was more about we couldn't instill everything that we wanted to do.
So some feature improvements that we could do for this type of scuttle security robot is to use like a higher torque, a 360-degree motor, perhaps a DC motor that could substitute the servo motor. And this could help apply more torque to consistently pull the Nerf gun trigger, because that was one of the problems we were running into quite frequently. We could also include a Nerf gun with a trigger that has higher sensitivity. So instead of having a different motor, we could just use a gun that's easier to pull the trigger. Additionally, we could also use a global scan of the whole room at the start and be consistently scanning for new objects when moving around the room. This is also to avoid dead zones. And lastly, we could also use a more central path through the room instead of following the closest wall, just so it's able to maybe see more points and not necessarily rely on the wall being there.
So this is our effort distribution. For week one, I was mostly focused on solving the Pi connectivity issues, working offline strictly through the GitHub. Week two was similar in that aspect, and then week three is whenever we were able to start working properly again. So tried to write the SLAM code. The previously mentioned technology limitations prevented that from working ideally. So then we began the final iteration of the navigation code, at which point in week four, we finished the navigation code, and then we're testing throughout the rest of the time.
I was working for the first week to help solve the high connectivity issues. And then after that, I left that up to Sam and Kian as I went and got the Nerf gun that was associated with the servo motor to be used. And then on week three, I assisted Sam with writing the SAM and the navigation code, which was finally used. And then week four, I helped debug any remaining problems in the code.
So on my part, instead of paying attention to the Pi connectivity, I decided to take the time to instead create the 3D printed parts that was used to connect the Nerf gun to the scuttle for week one. Then for week two, I was able to then attach the mount and the Nerf gun to the scuttle and began trying to figure out where I would place the servo and what type of code I would need for it. Week three, I was then able to mount the servo onto the Nerf gun after figuring out the place and getting the right servo code. And from there, it was trial and error, trying to figure out how to pull the trigger and how to make sure everything works there. And for the last week, it was collaborating with the other teammates to figure out if there's any more help that is needed in the other codes that was used.
So for the first 2 weeks, I was also trying to solve the Pi connectivity issue. And during this process, I was writing the obstacle detection code in the background offline, kind of like Sam was at the start. In week 3 is when I imported that code that I wrote for the obstacle detection into the Pi to properly be able to test it and debug any issues. And in week 4, I helped debug any remaining problems throughout the entire code. For the week objectives for the whole team, the first week that was mainly contributing to the Pi connectivity issues. Week 2, we mounted all the components onto the scuttle and integrating the servo motor, Nerf gun to get the whole mechanical side together. Week 3 is when we combined all the codes that we've written to be able to properly run the whole program and just be able to test it to make sure it works. And week 4, we were all just fine tuning the code just through testing and trial and error.
Does anyone have any questions?